again, and welcome to the second part of our lecture on the labor supply. So let's recap. Let's look again at our potential income and wage constraint, or otherwise known as the budget constraint. So here we have our budget constraint formula. Total income is equal to the wage times total discretionary hours minus hours of leisure. And so that equals hours worked. And we're multiplying that by the wage. So that'll be total market income, and then we're going to add on here non-labor income. Okay, and our space that we're looking at is income and leisure. And notice here that we have hours of work just underneath. So again, hours of work is just this T, which is the total discretionary time, minus the hours of leisure. So this is showing you how much hours worked. And of course, if someone works, for example, if someone takes 11 hours of leisure, then they're going to be working 5 hours. So these have to sum up to total discretionary time, which is equal to 16. Of course, if a person doesn't work at all, then their income is equal to YN, which is the non-labor income. In this example so far, it is equal to 0. The slope of the line is, of course, just the negative wage. So as people decide to start working, their income increases by the wage times the hours worked. And of course, the slope of this line, as we just mentioned, is negative wage, but we can clearly see that if we were to take the formula for the income and isolate leisure, because then we would know that's the variable on the horizontal axis, and so whatever's in front of it is going to measure the slope, and clearly if we work this out, we'll see that it's the wage W. Now, what happens if non-labor income increases or decreases? Well, we know the wage won't change if that's the case, and so the only thing that's going to happen is the budget line will shift upwards in a parallel fashion. What happens if the wage, say it increases? That's going to be depicted by a rotation outward of the budget line. For example, here we see that because of this wage increase, there's more income that can be made for every hour of work. Okay, so that's our potential income and wage constraint. The more steeper this is, the higher the wage. Now let's talk about our model. So in our model, we're going to have that individuals choose either income or consumption. So the income is going to be used to buy consumption, and they're going to be choosing that and leisure to maximize their utility. Okay, so up to this point, we haven't looked at the optimal decision yet. The optimal decision is going to be the point where the budget line is tangent to the indifference curve of the individual. And at this point, as we'll see, it will measure the marginal rate of substitution. Well, the slope of the indifference curve is the marginal rate of substitution. We'll talk about that in a moment. And at the optimum point, that is going to be equal to the wage. Any other consumption leisure bundle will not maximize the individual's utility. Okay, so let's look at an example. So here we have the budget constraint for an individual. We have our hours of leisure on the horizontal axis, income on the vertical axis. The individual wants to choose the point which maximizes their utility. So we take their indifference curve and move it in a northeasterly direction until it's just tangent to the budget constraint. So this is the most amount of utility this person can obtain given their potential linear budget constraint. In this example, this is the optimum point, and the individual will choose 70 hours of leisure or 40 hours of work. Let's look a little more closely at the optimum situation. So here we have at point P, the person here would be optimizing. They're maximizing their utility. They're getting utility associated with U star. Now, what would happen if they chose A instead? because after all, A would give them a lot more money. If they're at point A, they would get $1,100 in income, and that's much more than $500. But why aren't they choosing that point? Well, that point gives them lower utility. And that's because although they're getting more money, they're also having to work much more. What about point Y? You have an income that is $1,100, but if you look down at the horizontal axis, you see that the hours of work is 40. So, and then the hours of leisure is 70. Given this person's potential linear income constraint, they're not able to get to this point. Their wages aren't high enough. So this point is not feasible. So let's talk about the marginal rate of substitution. The definition is the rate at which a person is willing to give up leisure hours in exchange for additional income Y. So if we look at the indifference curve and we look at this region over here to the left, we see that this person, to keep them indifferent to a loss of 2 hours of leisure, you would need to give them an increase in income of $5. And so here, the marginal rate of substitution is simply negative 2.5. So if you take away, so you have negative 2 hours of leisure, you would need positive $5 to keep them equally happy. And that's the marginal rate of substitution. So that's the rate at which they're giving up leisure for income. So this person is willing to give up only 1 hour of leisure for $2.5. Now, along an indifference curve, the marginal rate of substitution, its absolute value, falls. And the slope of these lines become more steep. So for example, down here, the marginal rate of substitution would be negative 0.25. Okay, at this point in this area, the person already has a lot of leisure. So the marginal utility of leisure is lower than it would be up here. Okay, and so if you take away 2 hours of their leisure time, you don't need to give them as much income to make up for that. Because they have a low level of income, income's utility would, the marginal utility of income would be quite high here. So taking away 2 hours of leisure, you wouldn't have to give them as much income to make them equally happy. Okay, so in this, according to these 2 points, the marginal rate of substitution is negative 0.25. So in words, the person is willing to give up only 1 hour of leisure or is willing to give up 1 hour of leisure for only 0.25 Y. Okay, so the slope of lines tangent to the indifference curve is the marginal rate of substitution, and at the optimum point here, the marginal rate of substitution is going to equal the wage. And that's because, remember, the slope of the budget constraint is equal to the wage. It's negative. Marginal rate of substitution is negative. So we can just set them equal to each other and ignore the negative. Okay, so this is the optimum point. Let's interpret the tangency condition. So the slope of the indifference curve equals the slope of the budget line at the optimum. So therefore we have this. This is the optimal condition. Okay. We can rewrite the marginal rate of substitution as the marginal utility of leisure over the marginal utility of income. And so this is the marginal rate of substitution, and that's equal to the wage. And we can rewrite this just by rearranging it, and we can see that the term on the left here is the number of utils received from spending an additional $1 on leisure. Okay, so if you spend an additional $1 on leisure, okay, then this is the term that is representing that amount. This is the number of utilities or units of happiness you would receive, and that has to equal the marginal utility of income. And this is the utility derived from an extra unit of income which is spent on consumer goods. If these two things weren't equal, well, then the person could just rearrange their consumption plan so as to purchase more of the commodity that yields more utility per dollar. Okay, so either taking more leisure or more income. Okay, now let's look at a situation where an individual would decide not to work. Okay, so the decision not to work is actually a corner solution. So we know in our model here, someone not working would be choosing the point where T, total discretionary time, is equal to 16. So here that would be point D. And notice how the indifference curves are quite steep. If you remember from before, steep indifference curves represent individuals who enjoy leisure. And so clearly, if we were thinking of what indifference curve here maximizes the utility for the individual subject to the budget constraint, well, that is going to be point D. Okay, and so leisure here is 16, hours worked is 0. So this diagram is illustrating preferences for someone where their preference for leisure is so strong there's no desire to work at all in the labor market. Now let's talk about what the reservation wage is. Okay, so the reservation wage is, you can think of it as a sort of a threshold. If an individual can get more than their reservation wage, they will decide to work. So the reservation wage is a person's minimum amount that they would need to work. So we have some indifference curves here. Okay, we know this person is going to optimize here at E0. That's an interior solution. Okay, they would take this much leisure and then they would earn this much income. Now, how do we see what the reservation wage is here? Well, in order to do that, we look at the indifference curve that is going through the point where they would decide not to work. So if we have T units of leisure, this would be the point right here, and the person's indifference curve that goes through here is what we're going to use. So what we need to do, so on the diagram, the reservation wage is going to be a line that's tangent to the indifference curve at this point. Okay, and so the slope of that line will be the wage, and that will be their reservation wage. So if we draw a line through here, so R and R prime, this line is the reservation wage. If the wage that the person can get in the market is anything higher than this, then it will become tangent to their indifference curve at a positive number of working hours. Okay, here's another example of an equilibrium of a non-participant. Okay, so it's a corner solution. So this person would decide not to work. So given their preferences and this wage, their optimum decision would be to not work, and that's the decision that would yield them the highest level of utility. And here is their reservation wage. And so here we can clearly see that the market wage, which is negative W0, or sorry, well, it's W0, the slope of this line is negative W0. This wage, represented by this line, is less than the reservation wage. And so they're deciding not to work. If, however, the market wage were to increase, and increase greater than the reservation wage, they would decide to work, because their optimum point then would be somewhere to the left of T. Okay, so now let's talk about what happens to hours worked if we have a non-labor income change. So if our YN changes. Well, it depends on whether leisure is a normal or inferior good. If it's a normal good and incomes increase, then the workers or individuals will want to take more of it, will want more leisure. So if you remember from microeconomics, a normal good means that the quantity demanded for it is positively related to income. More income, you want to buy more of it. So if leisure, if we think of it as a normal good, higher income would mean we want more leisure. And then the opposite would be true for leisure if it was an inferior good. If leisure was an inferior good, if our incomes increased, we would want less of it. Let's look at an illustration. So for example, if we had a budget constraint that looked like this, we got our wage is W0. In this diagram, our wage is W0 as well. And then we have an increase in non-labor income. As we know, that's going to shift the budget constraint to the right in a parallel fashion. Okay? And if leisure is a normal good, then the amount of leisure will increase. So if it's a normal good, the new tangency point should be to the right of L0. So for example, here we go from L0 to L1. Now in the second diagram, leisure is inferior, so then we know if there's an increase in non-labor income, it should fall. So here in this illustration, this person's preferences are such that they would demand less leisure and work more. So most empirical studies suggest that leisure is a normal good. It makes more sense. And so for the remaining lecture, we will make that assumption. So we're only going to assume that leisure is a normal good. So whenever there's a change in income, then we're going to assume the person is going to work less and take more leisure. Okay, here's another example. So this is the typical case then that we're going to assume. We're going to assume that if there's an increase in income, wages held constant, that the person will decide to take more hours of leisure and work less. So that's like what we have here at P0, the optimum point. Before the increase in income, the person is choosing 70 hours of leisure. And after the increase in income, they're going to be the new optimum point is going to be to the right, where they are consuming more hours of leisure. But now what happens if the wage changes? Okay, so a change in the wage is a little more complicated. So a wage change can be decomposed into two effects. Suppose the wage increases. Well, there is an income effect. If your wage is higher, you're going to be able to buy more goods and services, including leisure. And so according to this, a pure income effect, the worker would reduce their hours. And recall, this is because we're assuming leisure is a normal good. But we also have a substitution effect. The wage is now higher, so that means you can make more money. The return to working is higher. So we would assume that the worker would substitute away from leisure and work more. So there's two effects going on here. So the net result then depends on which effect dominates the other. So let's look at an example. So we have our individual optimizing at E0. Let's have a wage change. So here the wage increased, the slope becomes steeper, and now we see that the person here is deciding to work more because their leisure has fallen. Okay? But this effect, L0 to L1, is the net effect. We want to decompose that into a substitution and income effect. Okay, so to get the substitution effect, we need to hold income constant and just have that the wage changes and see how that induces the person's decision, or how that reflects their decision. So if we were to take away the person's income so that they were on the previous indifference curve, we would end up being at point E prime. Okay, and so moving along here from E0 to E prime shows you the change in their decision based solely on the difference in the wage. So the wage was W0 here, we would like to be here, and if the wage is W1, so the steeper line here, we would like to be at E prime. So the substitution effect here is isolated, and it says that the person would reduce their leisure from L0 to L prime. After all, wages are higher and you get a higher return, so you'd want to substitute away from leisure and work more. So here the price of leisure is actually increased because of the wage increasing. And so the substitution effect says work more, take less leisure. And to isolate the income effect, we just look at the difference between E prime and E1. So if we give that person the income back and see where their tangent on their new indifference curve, we get that we'd be at point E. And so we can clearly see here that the income effect, which we know reduces work effort and increases leisure, because we're assuming leisure is a normal good, we would go from L prime to L1. So the overall net effect is that the amount of leisure is reduced from L0 to L1. And so the substitution effect is larger and dominated the income effect. They both work in opposite directions when we have a wage change, and how much the hours work changes depends on the size of the substitution and income effect. Here the substitution effect was larger, and then substitution effect says to work more, so this person's working more. Okay, here's another example, but in this example we're going to show the income effect dominating. So this person's optimizing here. They're facing an increase in their wage. They're going to choose to optimize here at N2. Okay, so now we can, this is different than before. So now in the face of a wage increase, this person, because of their preferences being a certain way, decide to take more leisure. So they're going to go in this direction and increase their hours of leisure. But remember, there's a substitution effect going on here as well, which would make them want to work more. So since the net effect, the overall effect, is for them to work less and increase their leisure, the income effect must have dominated the substitution effect. Okay? Now, what's the effect of a wage increase on participation? Okay, so the net effect depends on both the substitution effect and the income effect. Okay, if the income effect dominates, hours of work may decline, but for a non-participant, an increase in wages may leave the equilibrium unchanged or induce the individual to participate. Okay, so if we have someone who's not working, if there's an increase in the wage, if it's large enough and exceeds their reservation wage, they will start to work. If it doesn't, then nothing will change. They will not decide to work. Okay, now let's talk about the labor supply curve. So if you didn't realize, we actually can obtain enough information to plot a labor supply curve given changes in wages in our income leisure model. So at wages that are slightly above the reservation wage, the labor supply curve is typically positively sloped, where we have the substitution effect dominating the income effect. But there could be an income level high enough where the effects are reversed and the income effect begins to dominate the substitution effect. Okay, and so because of that, we can have a backward bending labor supply curve, which we'll see in a moment. So here we're just illustrating the effects of what could happen if the wage is increasing. So at a wage W0, this person is going to optimize by not working, because this would give them a utility of U0, which is the highest indifference curve given the budget constraint. Now if the wage increases to W1, we actually still get the same outcome, because the indifference curve, the highest utility that they can obtain is U0. Okay, so if you're pulling this up in the northeastern direction, this is the farthest you can go and just touch the tip of the budget constraint there. But now what happens if the wage increases to W2, exceeding their reservation wage, and it would be optimum for them to work and be at point E2. So now it would be optimum for them to work at point E2, at the level of work associated with E2. So if the substitution effect dominates, we know that wage changes, well, an increase in wage would lead to an increase in labor supply. Wages continue to increase until a point where the substitution effect and income effect offset each other, and then the supply curve bends backwards when the income effect dominates the substitution effect. Let's look at an illustration of that. So here we have a person that faces different wages. Their reservation wage, which is the slope of a line tangent to their indifference curve that goes through this point where they would not work at 110 hours of leisure. So that's $10. If we increase the wage to $13, this person would choose to work more. They would choose to have 90 hours of leisure, and the rest of the 110 hours would be for work. And so they would be working 20 hours here. Well, we have now a wage and hours worked combination that we can plot over here in the labor supply space, which is the wage and hours worked. So when the wage is $10, they don't work. That's their reservation wage. The wage is $13, they're going to work, and they're going to work 20 hours. So this point corresponds to this point. Now what happens if the wage increases further to $20? At $20, the person is going to take 70 hours of leisure, and the rest will be hours worked. So that will be 40 hours of work, because 40 plus 70 is 110. So that point corresponds to this. So wage is 20. If the wage is 20, the person would work 40 hours. Now, if the wage goes up again to $25 an hour, well, this person is actually going to take more leisure now. So here the income effect is dominating the substitution effect, because we're increasing leisure now. And so now the person is going to work, well, they're going to take 80 hours of leisure, and so the rest of the 110 would be used for working, so now it's 30. Okay, so now it's fallen from 40 to 30, and this is the point that corresponds to a wage, to when the wage is $25. Okay, so you can see we have a backward bending labor supply curve. So this is how we typically think this is. Of course, every individual is different. Some individuals, it would start to bend backwards at a much higher wage rate. Others, it could be a lower wage rate. It depends on how much they enjoy leisure. Okay, here is another illustration for you for your notes to have. So again, this portion of the labor supply curve is where the substitution effect dominates the income effect, and then when it starts bending backwards, the income effect is dominating the substitution effect. Okay, so let's do some practice questions. An increase in the wage rate will increase desired hours of work if the income effect and substitution effect cancel each other out. B, the income effect dominates the substitution effect. C, the substitution effect dominates the income effect, or D, accompanied by an increase in non-wage income? Which one do you think is the correct answer? Okay, the answer is in fact C. It's when the substitution effect dominates the income effect. Okay, next question. So here we have two indifference curves, U1, U2. We have 2 points here, A and B. Total discretionary hours is 400. We have our income on the vertical axis. And the question is asking us which of the following is true in the figure above. A, the wage is $4. B, the non-labor income is $400. C, the optimal number of hours to supply is 0. Or D, all of the above. Okay, well let's look at C. The optimal number of hours to supply is 0. Well, in order to find out the individual's maximization, to solve their maximization problem, we look for the highest indifference curve that is tangent to the budget constraint. And that point would be right here, and it would be at a positive number of hours worked of 100. So C is not true. B, non-labor income is 400. Well, non-labor income is the amount of income that you would earn if you did not work. So if you took all of your time and leisure, and we look up, so that would be point B, look over, and income is 200. So B is not true. Non-labor income depicted in this diagram is 200, not 400. What about the wage rate? Okay, so this is saying the wage rate is $4. So if the wage rate is $4, then we can calculate what this point C would be. Okay, so if the wage rate is $4, we're going to take 4, multiply it by 400. So if the person decided to work all of their discretionary time, they would work 400 hours. So we'd multiply that by 4, and we would get 1,600. And then we would add to that the $200 in non-labor income, and we would get this point C. And we would get that it equals 1,800, and it indeed does equal 1,800. So we know A is true. The wage is $4. Okay, here's another question. We have here some strange indifference curves. So we have two indifference curves, and they actually come down, we have them being negatively sloped, but at some point they turn around and become positively sloped. And they do that at this point here. So the question's asking, what do these indifference curves mean? Which one of these phrases here is correct in terms of these strange looking indifference curves? A, after a certain number of leisure hours is reached, additional leisure becomes very valuable. Okay, so that's A. After a certain number of leisure hours are reached, additional leisure hours have no value. After a certain number of leisure hours are reached, work hours are actually viewed as a good thing. And D, as leisure hours increase, additional hours of leisure fall in value, but after some point start to increase again. Okay, so what do you think? Well, let's look at an indifference curve and just think about an area on the portion before it turns around. In this area, if we take away leisure, we need to give the person extra income to remain indifferent. But on this side, positively sloped side, if we were to take away leisure, we would have to take away income, or we could take away income, and the person would remain indifferent. So in that case, on this side, work must actually be viewed as a good thing, because we can take away, if we take away leisure, we have to compensate for that by taking wages away. And so we could make, so if the person works more by having leisure fall, that's a good thing for them when we can actually take away income and make them equally as good off. And so, yeah, these indifference curves are quite strange, and they would suggest that after a certain number of hours are reached, which corresponds to this point here, which would be 50 hours, the value of working for whatever reason is actually positive. So it gives them utility. But in this, before this point, working would give them disutility. Okay, now we have the same diagram in the next question, and it's asking which of the following statements is consistent with the figure above. The market wage is $6. Low-income individuals receive a subsidy of $400 and face an implicit tax rate of 0. The optimum number of hours to supply is 50, or the optimum number of hours to supply is 0. Okay, so, well, let's start with D. What would be the optimal? Well, the optimal will be the highest indifference curve tangent to the budget constraint. So that would be here at this point, and that would correspond to 50 hours of labor. Okay, so we see that D is wrong, and that C is actually the correct answer. Okay, B says that low-income individuals receive a subsidy of $400 and face an implicit tax rate of 0. That's not true. They do receive non-labor income of $400, which is their subsidy, but if they start to work, it's taken back at 100%. It's clawed back at 100%, and so the implicit tax rate would be 100%, not 0. And the market wage rate is not $6. If you take the 400, multiply it by 6, and add in the non-labor income, you will not get 1,600. Okay. A backward bending labor supply curve occurs when, which one of these is correct? Leisure is a normal good and the substitution effect dominates at low wage levels. B, leisure is a normal good and the income effect dominates at high wages. At low wage levels, leisure is a normal good, but then an inferior good at high wage levels. And then D, leisure is an inferior good, and the income effect dominates at high levels. Which one is correct? And your other option here is E, both A and B. Okay, so if you guessed E, you're correct. So A and B are the correct answer. So let's think about the real world here and see if we have any empirical evidence for some of these things that we've talked about. So two research questions that are key and very important are as follows. Does labor supply behavior conform to the predictions of economic theory? And how responsive is labor supply to changes in the wage? So basically we're going to look here at labor supply elasticity. Labor supply elasticity measures the responsiveness in hours worked to changes in the wage rate. So we have that represented by sigma, percent change in hours worked divided by the percent change in the wage rate is represented here. So the labor supply elasticity is equal to the percentage change in hours worked over the percentage change in wages. And we can rewrite that as follows. If this coefficient for labor supply is less than 1, we say that it's inelastic. So if it's greater than 0 and less than 1, it's inelastic. And if it's greater than 1, we say it's elastic. So if it's inelastic, that means the percentage change in wages will induce a lower percentage change in hours worked. But if it's elastic, the percentage change in hours worked giving a percentage change in wages will be more. So this is a thoroughly researched topic. For men, many studies find that prime age men participate a lot in the labor force, and so we can usually just take a sample of working men and then correlate their hours worked rate and non-labor income. A sort of benchmark regression model that we would estimate to capture these estimates would be as follows. Here we have hours worked as the dependent variable, and we have that equals a coefficient beta times W, which is the wage, plus gamma times V, which is non-labor income, plus other variables. So here, beta would capture the effect of wages on hours worked holding income constant. So that would be the substitution effect. And here we would be looking at a change in income. So gamma here would reflect a change in income holding wages constant. And then other variables, so we would have control variables in there to try and ensure that we're looking at a causal effect. There's a lot of variation in the elasticity estimates. Some attempts have been done to sort of determine which estimates are most credible. On the whole, it's found that for males, the elasticity is roughly around negative 0.1. Okay, so in that case, the income effect tends to dominate the substitution effect for men. So a 10% increase in wages would actually lead to them taking 1% more leisure. Okay, so in terms of breaking this negative 0.1 effect down into an income and substitution effect, typically studies find that this can be broken down into a 1% increase in hours worked because of the substitution effect, but that's offset by an income effect of 2%, and that's how we end up getting 1% of the net, which is the net effect. Okay, so labor supply of women. There's also been a lot of research done on this. If we look across countries, there's substantial differences in the participation rates of women. However, over time, women's participation rates have increased. And in many studies on the elasticity, it's found that the substitution effects tend to dominate the income effects. So that's the opposite of what we found for men. If we look at data for different countries, so what we're plotting here is the growth rate of female participation against the percentage change in the wage. If we have an increase in the percentage change in the wage, there tends to be a positive relationship, and so female participation, that percentage change increases. And it seems to be that one can say that the labor force participation rates grew fastest in those developed countries that experienced the highest increase in the real wage. Okay, so let's do some more practice questions. So here we have our model. We have illustrated here an increase in the wage from W0 to W1. Okay, and the question is saying, given a wage increase from W0 to W1, the distance L prime and L1 represent what? A substitution effect, an income effect, the net effect of both the substitution and the income effect, or the equilibrium choice for hours worked. Okay, so let's think about this. Well, we know if we look at point E0 and E prime, we have the wage being W0 for the optimum at E0, and then we have the new wage, which is higher. These two lines are parallel, being tangent at this point, E prime. We know, comparing these 2 points and below, that that's going to give us the substitution effect. Okay, we're holding income constant, but we're looking at changes in the wage. And so the substitution effect is from L0 to L prime. But the question is asking what L prime is to L1. Okay, so we have two other options. It could either be the income effect or the total net effect. Well, we know that the difference between E prime and E1 is the income effect, because that's all we're changing. We're doing a parallel shift here in income and seeing how that affects hours worked. So going from L prime to L1 represents the income effect, and so the answer is B. Okay, next question. So we have a similar diagram here on the right, and the diagram is consistent with all but which of the following characteristics? Okay, A, for the worker, leisure is a normal good. B, the worker is on the backward bending portion of the labor supply curve. C, the substitution effect associated with the wage increase dominates the income effect. The increased price of consumption relative to leisure caused the worker to substitute away from leisure, and the worker is better off after the wage increase. Okay, so let's think about A. For the worker, leisure is a normal good. So if leisure is a normal good, that means if there's an increase in income, for example, we know between point E prime and E1, the consumer is facing a pure income effect, and what do? They take more leisure. Okay, so it's true that leisure is a normal good in this illustration. Is the worker on the backward bending portion of the labor supply curve? Well, if that was true, then for this particular wage increase, they would increase their amount of leisure. Do they do that? So let's see, they're originally at E0. They're faced with a wage increase, and what do? They decide to work more and take less leisure. So they're on the upward portion of the labor supply curve, not the backward bending or negative sloped portion. So B is not correct. We know here that the substitution effect goes from E0 to E prime, and the income effect is from E prime to E1. So clearly here the substitution effect is higher for this wage increase than the income effect. And so actually C is the answer to this question. Now suppose that the labor supply elasticity coefficient is 2.5. Which of the following statements is correct? So I'll let you take a look at them. Okay, so A, okay, so if the labor supply elasticity coefficient is 2.5, then if there's a 10% increase in the wage, that means that hours worked will increase by 2.5 times that amount. Okay, so then we know that it must increase hours worked by 25%. Okay, now since this is greater than 1, we also know that labor supply is elastic. Okay, so that rules out A, and it rules out C as well. And we also can rule out D because it says 2.5%. So we know that the correct answer is B. Okay, so thank you for listening to this lecture. In the next class, we're going to look at policy applications. And so we're going to use our model to analyze the effectiveness of various income support programs like welfare. Okay, thank you very much, and we'll see you next time.